Okay, so in previous lecture, we are discussing about the multi-cavity mold design, right? Okay, so in previous lecture we have discussed about the how to prepare the layout, है ना? So basically this is the two cavity which we for which I am preparing the multi-cavity. Okay, in which we have learned about the mold based system right now. Okay, see this is nothing but you can see that this is the cavity half, or you can say that this is the moving fixed half, right? Or this portion is nothing but this is the moving half of the mold, right?
Yes.
Okay, so in which this is the what is the name of this plate, tell me. One minute. What is the
Which
name
one?
of this plate? Core housing,
Which one? Yeah.
है ना? Spacer, this is nothing but spacer, है ना? Spacer
Yes.
is nothing but it is responsible for providing this space to the ejector grid, right?
Yes.
Okay, or what is this?
Back plate.
Back plate. Okay, so this all the combination is known as the moving half, है ना? And what is this here? This is the interlock.
Interlock.
Acha, what is the purpose of the interlock into the core insert or the cavity insert, tell me?
Proper alignment of
Proper alignment of the core and cavity insert, right? So for the proper alignment of the complete housing and the complete mold base, we will use guide pillar and the guide bush, right? But right, apart from the guide pillar and guide bush, we have to use this interlock also. Why? Because we have to align this core and cavity first of all, right?
correct.
Okay, so understood. See, this is nothing but this is the moving half portion, this is the moving half portion, है ना? और अच्छा, if you have any question query by extracting this core and cavity for this component, have you extract the core and cavity for this component, duster component, tell me.
Yes, sir.
Okay, so here will be the draft during this designing of this insert, right?
Hmm.
Okay, so you have provided that.
Yes, sir. Last time we discussed about this.
Yeah, the who is talking? Vrush, right?
Yeah.
Yes, okay. So Vrush are only students are present at that in that lecture, right? Okay. See, so this is the multi-cavity mold base. You can say that multi-cavity. Basically, we are preparing the two cavity mold, right, for the duster component. And in previous lecture, we have discussed about the how to prepare the core and cavity extraction for this component. Okay. Okay. So we have covered the complete mold base right now. Okay. Understood? Okay. Acha, what is the purpose of this space? Tell me again. I'm revise something, right? Some points. See, what is the purpose of this space? And there is no space between this core and cavity, right? So here, this is the space here. So what is the reason of that? Vrush, tell me. The space between the cavity housing and the core housing.
The proper alignment of core and cavity.
Yeah.
So housing should not affect the core and cavity.
Yeah. So but for the force distribution, we have to use one element, which is the
Pressure.
pressure pad.
Yes.
Yes, which is the pressure pad. Okay, so basically you can say that pressure pad, this surface or top surface of the pressure pad is equal to this surface, right? To the insert surface, right? Right? Both will be on same plane. See, this face and this face both will be on same plane, right? So this is used for the force distribution. Okay, understood. Okay, so your mold base has been prepared. Okay, so here now we have to design the guide pillar and the guide bush. Guide pillar and the guide bush. Na? So what is the first question? If we are designing the guide pillar and guide bush, then what is the purpose of the guide pillar guide bush? Alignment, right? Alignment. Okay, so how to calculate the guide pillar and guide bush? See what is the guide pillar guide bush? It is providing the proper alignment to the mold base, because we are using right now inserts. If we are not using insert, then so it is basically it will provide the alignment to the core and cavity and the complete mold base. But if we are using the insert, core and cavity insert, then what is the meaning of that? It is providing the alignment to the mold base, right or wrong?
Yes.
Okay, see here, this is the moving direction. So basically you can see that, see, the guide player will be in moving side, right? So it will be in core side, you can say that, right? Understood? Okay. If I am talking about the material of this guide pillar and the guide bush, what will be the material for that? For these two elements, tell me. We have to use EN353 or the EN31. EN31. Acha, what is the reason of that? Using this material, tell me. What is the reason of this? If we are using this material for the guide player and guide bush, so what is the reason? The material should be hard for this component, right? Right or wrong?
Yes, sir.
Okay, so what is the hardness of EN353 and EN31? It is around more than 58 to 62 HRC, है ना? Like this.
Yes. Okay.
Okay, so that's why we have to use this material, right? Now see, this is the moving position, right? This is the moving direction for the guide player and the guide bush. So center alignment is very important. Why? Acha, what is the reason of that? Why we require center alignment? Tell me, why we required center alignment? What is needed of the center alignment? Because we need a quality component, right? We need a quality component. So for example, if there is no center alignment, there is a two axis. First axis is for the core insert, you can say that, and second axis will be for the core insert. See, this is the cavity, this is the core, for example, right? There is a two axis of this. So because of this two axis, what will happen here? Component dimension will be vary, right? For example, like this, है ना? Here will be the wall thickness is around 2 mm. Here will be the wall thickness will be around 1 mm. Okay, but component wall thickness should be same, right?
Correct.
It is around 1.5 mm. It should be 1.5 mm, but because of the misalignment, what is happening here? Here is the 2 mm, here is the 1 mm. Okay.
Got it.
Okay, that's why. Okay, so for the good quality part, you can say that, है ना? For the uniform wall thickness, center alignment should be there. Okay, see, है ना? See, for example, this is the mold base. If we are using mold base, then we have to use the guide player and guide bush, है ना? Or if we are using the insert, so for the center alignment, we have to use the interlock for the center alignment, right? Understood? Okay.
Yes.
See, है ना? So how to calculate guide pillar? So basically, if we are designing the guide pillar, so first of all we have to find out the guide pillar diameter. Okay, now guide pillar diameter is depending upon two things. Okay, first is mold weight and second one is pillar length. Mold weight and pillar length, and we have to use this for this formulas here. See, by which we will get the D. Here you can see that W is nothing but it is the weight of the mold base. So that's why we have designed the complete mold base. Yeah, right or wrong?
Yes.
Okay, we have a complete mold base for the weight, right? For the weight. And L is nothing but total pillar length. Achha, how to decide the pillar length? Any idea? No? Okay. So E is nothing but Young modulus of material, which is the constant material depending upon the material use we are using, right? Okay. Del max is nothing but deflection of a steel, which we have to assume. Like for example, we have a 1 mm dimension. So in 1 mm dimension, there is a possibility that the material will deflect around 10 micron, right? So we have to assume this, that it can be deflect also, right? Okay. Now what is the meaning of mold weight? So it is depending upon the solid density. Now we have to put the solid density for calculating the mold weight, right or wrong? So what is the solid density for the MS? 7.85.
Density.
Okay, or instead of MS material, for example, if I'm using P20 material, so for the P20 material there is no change, right? It is about 7.86 or the at 7, right? So there is no major changes into that, right or wrong? So that's why
Correct.
for the complete mold base we can take 7.85 gram per centimeter cube, right? Okay. So here you can see that the mold weight is depending upon the density. है ना? So density multiplied by volume, you will get the mass, right? Okay. Pillar length, pillar length. Acha. So here you can see that here from this point to this point, this portion will be in core part, right or wrong? Core plate. You can see that, right? And this is the pillar, and pillar will be enter into the bush, right or wrong? And this is nothing but this is the initial dimension of the cavity. You can see that this is the initial phase of the cavity, right or wrong?
Correct.
Okay. Now for example, if we have this core, and we have this cavity. So for example, I have a component like this. This is the component, for example, right? Okay. So here you can see that your guide pillar length from this point to this point, your guide pillar length should be more than this component height, right or wrong?
Correct.
Why? What is the reason of that? What is the reason of this?
To eject the part.
No, not for the eject the part.
It should not come out from the cavity.
Just for an example, if your guide pillar height is like this, for example, this is the your guide pillar height from this point to this point. Okay. So what is the purpose of guide pillar? Tell me first of all.
It needs the proper
Align the component, core and cavity, right or wrong? Or this is the height of the core. See here. So it should be more than this the component height. So first of all, this pillar should be enter into the bush, right or wrong? This pillar should be enter into the bush first, right or wrong? See, for example, this is the cavity. See, so we have to align this 2 point, right or wrong? First of all, we have to align this point, right or wrong? This is the center point of the core, this is the center point of the cavity, so we have to align this point, right or wrong? Okay. So by the guide plug and by the guide bush, we are aligning this core and cavity, right or wrong? So first of all, pillar should be enter into the bush. Understood or not?
Yes, sir.
Or confused? Understood or confused? See, for example, I have this C, right? This is the fixed half portion, C, or C, like this, and here C, right?
Okay.
Again, 1 minute. See here. Okay. So basically this is the core. For example, this is the core and this will be the cavity, right? Into this mode. This will be the cavity, right?
Correct.
Like this. Okay. So here this is the pillar, right? This is the pillar and this will be the bush. So first you have your pillar should be enter into the
Bush.
this bush.
Cavity.
Why? Because we are using the pillar and the bush for aligning this core and cavity for alignment of this core and cavity, right? So first of all, this pillar should be enter into this bush. So that's why it should be more than component height, right? It should be more than component height. Okay, just like a this space, right?
Got it, sir.
Understood?
Yes.
Okay, so here you can see that 1 minute. Okay, so understood about this? Okay,
Yes, sir.
so that's why, so here, so this diameter is depending upon the mold weight and the pillar length. Okay, so here you can see that from this point to this point, this distance is about L equal to component height plus 20 mm. Why I am taking 20 mm? I can take 10 mm also, right? I
But
can
there is
take
a
10 mm.
radius in
Yeah.
start.
So basically we have to take the chamfer and the radius at starting, right? For the easy entering into the bush.
Bush.
Okay, so that's why we have to take this distance. So that's why I am taking 10 mm for this, and 10 mm is the clearance, right? That's why I am taking 20 mm here. Is it clear?
Yes.
So by which we will get the length,
Length,
right?
okay.
Length, pillar of length. Okay, pillar length. Okay, so for example, our pillar length is about from this point to this point, right? Okay, so for fixing this pillar, we have to take some distance, right? For example, I can take around 20 mm, right, for fixing purpose. Okay, this is not mandatory that we have to take this distance, because we have to fix this pillar into the plate. Okay, into the plate. So for fixing purpose, for example, I am taking 20 mm only. Okay, why? Because for example, we have a plate, and from the back of the plate I can bolt this pillar, right?
Yes.
Understood? So that's why I am taking only 20 mm for this, and I will add. So for this purpose I am taking only this length. So this length will be around component height. For example, this is the H, 20 mm for the clearance and 20 mm for the fixing. Is it clear?
Yes, sir.
Okay, so this is nothing but this is the pillar length, you can say that. This is the pillar length. Understood?
Yes, sir.
Okay, now once you get the pillar length, you will get the diameter by the formula. Okay, and once you get the diameter, you can find out this shoulder diameter, which is about d1 equal to d plus 8. It means 4 mm per side we have to take. This is the manufacturing facility, right? Okay, and again, if you want to design a collar, after shoulder, if you want to design the collar, then it will be d2, which is d1 plus 8. So 4 mm again for the collar, per side. Is it clear?
Yes.
Okay, now example for the calculation. For example, if the mold weight is about 250 kg, okay, and the one pillar length is required about 60 mm, then what will be the guide pillar diameter required for the mold? Okay, now see here, given data is around, see this W equal to 250 kg, L equal to 60 mm. So multiply by 4. Why? Because number of guide pillar will be there, 4 we are using, right?
Yes.
That's why. Okay, now see, use this formula, you will get some value, D equal to 25.7 mm. So once you get this value, what is the meaning of this? When you got this value, so what is the meaning of this? So this is nothing but this is the nominal diameter of the shaft.
Correct.
This is the nominal diameter of the shaft which you have to use, or more than this value you have to use, right?
Okay.
Understood? Okay. So this is nothing but diameter of the guide pillar should be more than this calculated value. Understood? Now here, see here, okay? Okay, I'm hiding just top plate and cavity plate, and this will be the insert. And where will be the guide pillar position? Here will be the guide pillar position, right? On the core side. Okay. So take the first of all, what is the weight? What is the weight of the mold? Okay. Put the density. What is the density of the MS again?
7.8.
7.85. Okay. See, gram per centimeter cube, and you will get the complete weight of the mold, right? 1 minute. Weight means you can say that mass, right? Okay, which is about 211.64. Okay, so maybe round figure I can take 220, right?
Okay.
220 I can take, right? Okay, and what is the length required? See here, what is the guide pillar length required? Tell me. what is the component height? Say, 1 minute. Component height is around 26. Okay, 26 mm. Component height. So
Plus 20.
I can assume 26 by 30. Okay, I can assume 30 mm.
Okay.
So 1 minute. Here, so 30 mm is the component height plus, okay, 20 mm for the clearance and 20 mm again for the
Fitment.
fitment, okay, or the fixing of that pillar, right? So that's why 30 plus 20 plus 20. Okay, tell me, what is the total?
70.
70. So 70 multiplied by 4,
240.
240. Okay, so 240 mm is nothing but it is the guide pillar. Guide pillar length. Understood? Okay, now take the same formula. Take the same formula. What is the weight of the mold? Tell me.
220 kg.
220 kg. Okay, length of the pillar
240.
240. Okay, okay. See, what is the diameter? Guide pillar diameter 99.59. Is it correct?
No, sir, 26.
No. So we have to divide by the 4 number of guide pillar. Number of guide pillar. We are using 4. For example, for this mold, if we are using only single shaft, then we have to take the shaft into the center, right? Which will have diameter around 99 or the 100 diameter, right or wrong? But we are using 4 diameter, 4 shaft, right? That's why we required only 25. We required 25 diameter, 25 mm diameter, right?
Yes.
Understood? Okay, so more than 25 I can take any value, around 26 I can take, 28 or the 30 I can take, right? Understood?
Yes, sir.
So here, see, so here I have taken the diameter which is around 26. See here, 26. Okay, just extrude this. है ना? How much I have to extrude this circle?
70.
है ना? I am extruding, no, not 70. Here I will extrude
Okay.
30 mm, right? So 30 is the component height, right? And plus 20 mm is the
Clearance.
right clearance. Okay, and click OK. See, right? Or take the chamfer. See, take the chamfer. Okay, okay. I am taking, this is the shaft, but I have to take the shaft completely, right?
Yes.
है ना? Completely I have to take shaft. Here, take the radius here. Okay, है ना? See, this is, what is this? Collar.
Color.
I am taking collar. I am not taking the shoulder here, right? Okay,
Yes.
I am taking just collar here. Okay, so here 4 mm per side. Okay, unite with this. One minute, unite with this. Yes. Okay, understood. Okay, so this is nothing but this is the guide pillar which we are designing right now. Okay, this is the guide pillar. 1 minute. See. Okay, so into this guide pillar I am taking a tube. Okay, I am giving the position to this tube. See here. Okay, and taking the pattern. Acha, what is the purpose of this? Tell me. See. Acha. See, for example, here I am taking the bush, right? Bush, and this is the bush here.
So
Okay.
air gap maybe to avoid the
To avoid the
vacuum creation.
yes, of course, है ना? And the oiling purpose also. Okay, so this groove basically help to slide, or the basically what is the purpose of this guide pillar and the guide bush? To provide the sliding motion. No, not sliding, clearance fit. Okay, clearance fit. What is the fitment of this? Both clearance fit, right? Okay, clearance fit. And what is the purpose? Alignment, a proper alignment. So there will be a very less tolerance, you can say that, right? It will be in clearance. So basically this will be the slide fit, right? Understood or not? There is a three type of fits here. Right now if we are considering for the mold, so there are three type of fits. First is the clearance fit, and a second one is press fit, and or the press fit or push fit, sometime you can say that, and push fit, right? Push fit. Okay, so only two type, na? Clearance fit and the push fit. Okay, is it clear?
Yes.
Okay, so clearance fit we have to provide into the guide plate and the guide bush, na? And if for example if I will apply the push fit, so where I can apply the push fit?
When we not need any sliding motion or something.
Basically where we need a fitment, a complete fitment, for example between the core and cavity insert, local insert. For example you have a core like this, and into this core we are using a local insert like a pin. So into that we need push fit or the press fit. Understood? Okay, so basically what is the use of these grooves again? To provide the smooth motion, है ना? And because of these grooves we can avoid the suction or like that behave, right? Understood? Okay, just mirror this 4 pillar, see? Okay. Understood or not? Understood? Okay. See, from this cavity I will extract the bush also, okay? And see, this diameter is 26 and I am taking here 34, and 4 mm per side, right? And just splitting this portion, see, and you will get the bush portion, right? Bush, see, okay. See, tell me you understood or not? Right now we are designing the multi-cavity mold, okay? In previous lecture we have discussed about the layout selection, है ना? How to select the layout, right? Which is depending upon the manufacturing feasibility also. Okay? Okay. See, we have a component, see, one component and another component, right? Okay. So we have two components, see here. Okay.